Hello friends, welcome to our channel, and in this video we are going to learn about a practical in which we have to find the coefficient of thermal conductivity. As you can see on the chart or the journal, the aim is to determine the coefficient of thermal conductivity of a given solid in the form of rod, and yes, it is by using a method that is called Forbe's method. Forbe is the name of scientist who has discovered this particular method to determine the thermal conductivity coefficient. Okay, so basically, yes, whenever we are talking about the thermal conductivity, you might got the idea that we have to heat something, we have to use the flame, we have to use the burner and all. Yes, it is true. And yes, herefore we require a metal rod, of which we have to find the thermal conductivity, then thermometer and a scale, a stopwatch, and yes, obviously here not written but the burner and the gas cylinder and all. So this is the final formula by which we can get the coefficient of thermal conductivity. This K is the notification or notation for the conductivity coefficient. We have already seen in one of the previous practical, that is Lee's method. So same thing in this particular practical. We have to use, or sorry, we have to find the thermal coefficient or the coefficient of thermal conductivity of a metallic rod. There we have found for the insulating material in case of Lee's method. Okay, now this is what the formula we have to use, and we will see the theoretical aspect and all, or this journal we will get in your particular description box link. Don't worry about it. Next we will see this is what the theoretical aspect, how to find these determination, how d theta by dx, and theta is actually the temperature. Now let us move towards the experimental setup, how the experimental setup will be diagrammatically, then we will go to the actual experiment. So this is what actually the thing where in which we have kept the water, and we are continuously boiling the water, and this metal rod is deep into the water, and yes, that is what the different four thermometers are arranged on that particular rod. But in actually our practical experiment, we are not using this particular part, means we are not using the boiling water, because the getting boiling or thermal energy from boiling water to the metallic rod, it is little bit more time consuming. That's why we will directly heat, we will just take out this what we can say, the vessel, and directly heat this particular metallic rod. This is of iron material, that's why we can directly heat it, and it will reduce some time consumption or time period, and we can do the experiment a little bit comparatively a little bit faster. Okay, so these are different four thermometers we will arrange, and obviously this is what the thermometer which is very close to the hot end will have more temperature, and as we are moving from this point to this point, the temperatures are going to be decreased, and that is obvious. The heat energy is transferring from this point to this point, and that's why more temperature will be at the very first thermometer. Okay, that we will see again when we are taking the readings and all. Next we will see how to take the readings and what is actually the procedure to follow. So first observation table, we have to find first of all the serial number and the distance from hot end. That means first of all we have to measure by taking a meter scale how much is the distance of each thermometer. So yes, if you see this is actually the procedure, or this is actually the diagram. Here is the burner, we will use like this, and we will directly heat it by the burner. And here is first thermometer, second, third and fourth. We have four thermometers. Okay, so what we have to measure first of all from this end, what is the distance of first thermometer. Similarly for second thermometer, third thermometer and fourth thermometer, that we will have to note down here. Four thermometers, serial number 4, and 4 distances of each thermometer from this hot end. And then once the saturation, that means what happens, this heat energy is transferring from this point to the as possible as maximum to the total rod. Okay, and one point will reach, we call it as saturation point. That means above which initially we will find that this temperature is rising fastly, then this and then this and this, but after some time a saturation point occur, that means above which the temperatures are not going to be increased. And once that saturation point occurred, now we have to note down the temperatures here. What is the temperature, maximum temperature or the saturation temperature of first thermometer. corresponding to the distance. So first, second, third, right? We called these are the saturation temperatures, and that will be the first observation table. And now for the second observation table we have to do this. That means for second observation table, simply we have to heat this central. Actually we have 5 thermometers. We have arranged 5 thermometers in actually our practical lab. So 5 thermometers are there, and you have noted all the readings, saturated readings, and the distances of each thermometer. And nextly what we have to do, once you got noted the saturated readings, then we have to do the direct heating. That means this particular setup is fixed on a wooden box, and but this burner we can move here and there. So directly heating we have to do to the third thermometer. To the third thermometer means center thermometer, just left 2 thermometers on this side and 2 thermometers on this side. So heat the directly by taking burner. So we can take the burner here and heat the central thermometer directly. And let us consider theta 3 is the saturated temperature of that thermometer. So we have to heat it by plus 20 degrees Celsius. Means if theta 3 was the earlier temperature or saturated temperature of that thermometer, so we have to heat it till it increases by 20 degree Celsius. Okay, and once it goes to 20 degree Celsius, then stop the heating, then stop heating, switch off the gas cylinder, and then make another table in which we have to note down the serial number and time and the temperature. These are only the 3 columns in the second observation table. Okay, so serial number 1. So time, let us consider first of all how much it is. 0, time 0, we are starting from 0 second, time in second. For 0 second, let us consider what will be the temperature. So this is the final temperature. This will be for 0 second theta 3 plus 20 degree Celsius. And now stop heating after note down this reading. Then second reading will be 30 second. After every 30 second, now note down the decreasing temperature. Since we have stopped this heating, what happens due to the atmospheric temperature or the room temperature, what happens, that rod or that central temperature, central thermometer or the position at which central thermometer is attached, that position or overall rod is starting cooling with respect to the room temperature, and slowly what happens, this temperature decreases. So for 30 seconds, let us consider we have some reading here theta, then for next 60 seconds, and so on. So till we have to count the time after every 30 second, 90 second, till the temperature comes to the room temperature. Temperature comes to the room temperature. Let us consider 30 degrees Celsius up to 30. If it is if you are performing this experiment in summer days, then it may be 35 or 40, depends upon the conditions. Okay, so this is what the second observation table, right? And finally, yes, that is what we have to do here. To get the final expression or to get the final value, we have to use this particular formula. Okay, now friends, let us move towards the experimental part, and then we will understand how to perform the experiment, right? Okay friends, now let us come to the experimental part of this particular experiment, in which we have to find the thermal coefficient, or we can say the thermal conductivity coefficient of this metallic rod. So this rod is of iron, you can see, and as I have shown in the diagram also, we have arranged 5 thermometers on this particular rod, and now which is going to be heated. Now the heating is continuously started. So the heating process is going on. So this burner, the flame of this burner is heating this particular rod, and the thermal energy is now transferring from this point to this end, or we can say this end to this end. Now if you see this point will be more hot, this point is less as compared to the, again as we are moving from this point to this point, or hot end to cold end, we can say for our convenience. So what happens, the temperature or temperature is going to be decreased. Now this is what our first thermometer T1, T2, T3, T4 and T5. Okay, now what I said earlier, we have to wait till the saturation temperature occurs. Saturation temperature means what? The temperature after that the temperature is not going to be increased even though the heating is going on. Okay. Now here in the first thermometer it is 70 degree about, okay, about 70 degree, but still it is increasing. After a 15 or 20 minutes, what happens? These temperatures becomes constant. That is what we call the saturation temperature. Once they become constant, what happen? Or before that, we have to note down the distance of each thermometer from hot end. So this is the hot end. Just note down the distance of each thermometer. So I will just take the first of all, what is the distance of first thermometer? So first thermometer is at a distance 18 centimeter. First thermometer is at a distance 18 centimeter, and now onwards all the thermometers are equally spaced. So simply just measure the distance between any two successive thermometers and we have to add it into 18 centimeter. So the distance between two thermometer is 9 centimeter. So this is 18 first thermometer for first observation table, right? So for first observation table, serial number 1, that means thermometer first, it is of 18 centimeter from the hot end. Add 9 for the second reading, then add 9 and so on. So this is what your first observation table, first column, distance from hot end. Now let us consider after 20 minutes the saturation temperature occurs and all the temperatures or all the thermometers are not increasing temperature after that. Okay. Then note down those maximum temperatures. So after note down that maximum temperature, the first observation table will be completed. Okay. Now after that, what I said, you have to heat the central part or the central thermometer position directly. That is called direct heating. And how much you have to increase the temperature? By 20 degrees Celsius. Earlier let us consider it was 40 degrees Celsius. You have to go, or whatever may be the initial temperature, we have to raise it by 20 degrees Celsius. So how to go to the direct heating? Simply I told you, take the burner in your hand and heat it directly at this position. Okay, this is called direct heating. So I am heating it directly, and what happens? Due to this direct heating, the temperature increases suddenly of third thermometer, or we can say the central thermometer. Now how much you want to raise it? By 20 degrees Celsius. Now let us consider it has been increased by 20 degrees Celsius. It was earlier 40 degrees Celsius. Now it goes to the 60 degrees Celsius. As it reaches to the 60 degrees Celsius, then stop this heating. Stop the heating. So yes, we have stopped the heating, and take the stopwatch in our hand, and now it is at 60 degrees Celsius. Note down this for 0 second and then stop the stopwatch and keep here, because stopwatch has to be run continuously. After 30 seconds, again you have to note down the reading of that thermometer only. Now forget about these 4 thermometers. Okay, after every 30 seconds, what happens? The temperature now starts decreasing. The heating has been stopped. So the temperature decreases, and now for each and every 30 seconds, you have to note down the reading. So for first 30 seconds, it is come. Yes, for 30 seconds, note down the reading. Again, it goes to the 60, then 90, then 120, and so on. So up to what temperature you have to note down the reading? Up to the room temperature. Up to the room temperature. Okay. So once you got these readings, then we have to go to the calculation part. Calculation part, yes, it is very simple. Only here we have to take the 2 different observation tables. Initially we have taken the distance of each thermometer from the hot end and their maximum temperatures, and later on we have heated the central position on which the third thermometer is mounted. Directly we have raised its temperature by 20 degrees Celsius, and then we have stopped the heating, and after that we are measuring the decreasing temperature of that thermometer, third thermometer only, after every 30-second interval, and we have to do it till it reaches to the room temperature. Once it reaches to the room temperature, the experimental part is over. Now next we have to see the calculation part. Okay, so let's move towards the calculation part. Yes friends, this is what the calculation part. See here, we have taken the 5 different readings of distance from hot end, means this is the distance of first thermometer from hot end, then this is for second, third, fourth and fifth. So 5 temperatures, or sorry, 5 thermometers and 5 different readings from the hot end. and we have heated near about half an hour, then we got that these are the saturation or the maximum temperatures above which it is not increasing. Means after that we have kept it for 5 minutes again, and we find that even though we are continuously supplying the heat, the temperatures are not going to increase. That means the saturation point has been occurred. So that is what the first observation table just I told you. So this is for first observation table, in which simply we have to note down the distance of each thermometer and corresponding maximum temperature. Okay, now let us draw initially, or here two things we have to we required is this one of them is the specific heat of the material, and since we are doing with the material which is iron material, so it is 0.1, and the density of material, that is obviously of iron, it is 7.8. so these things we will require. One is S and another is rho. This specific heat S and this is rho. So these two things required. Now this is what the first observation table, and as soon as we got the first observation table, then we have to move towards the second observation table. Means after heating the central thermometer or central point, and then stopped it or stopped heating and start the time. So this is what, let us so initially it was 42 second, 42 degrees Celsius. See here, the central thermometer temperature is 42 degrees Celsius, and what I am saying, add or heat the central point till increases by 20 degrees Celsius, means we have to go up to the 62 degrees Celsius. So that is what we have done here, and once it reaches to the 62 degrees Celsius, stop the heating, and now stopwatch has to be started. So for 0 second the temperature was 62 degrees Celsius, and now after every 30 second note down the decreasing temperature. Now you can see the temperatures are decreasing continuously. See here, and we have to come till the room temperature, or we can consider till the temperature which is below the initial temperature. So initially it was 42 degrees Celsius, so we can come up to near about 39 or 40, it is also sufficient. Okay, now these are what the two observation tables. Now let us come to the graphical point. So once you have got the first observation table, this is the graph which is drawn from the first observation table. So from the first observation table we have to plot a distance of each thermometer on x axis, and whatever may be their corresponding temperature theta, this maximum temperature, on y axis, and we will find, yes, obviously as the distance increases the temperature is decreasing. So 5 points will be there, and draw a curve in from which maximum points has to be gone. So this is one of the point, this is one of the point, this one is, and this one is. So as possible as maximum points we have to take it from the curve, and then we have to find two different slopes also, theta d theta by dx at x1 and d theta by dx at x2, right. So this is what we can, so here one of the slope is found here and another slope you can found here. So this will be d theta by dx at x1 and d theta by dx at x2. So because these values we required in the final expression. Okay, so this is the what first graph. Now from the second observation table, let us move towards the second graph. In the second observation table, we know one of the factor is time and another factor is temperature. In first observation table, one of the factor was the distance. Now here, yes, on this axis we have to draw the time. Okay, and here obviously theta, temperature, right. So obviously there are number of readings, maybe 50 readings possibly, and just draw similarly. As we know, the time increases, what happens, the temperature decreases and it comes to the room temperature, but we have taken readings up to 40, oh no problem. And yes, the draw the similarly we have to plot the curve which should go through as possible as maximum number of points, and it is also a smooth curve. Okay. So after drawing these, again we have to take there about 12 slopes of this, 12 slopes. So to take the 12 slopes, one of the slope I will take like this. So I am talking about this slope. So after taking this slope, take its central point also. Central point, it is what, 50 degrees Celsius. Now by taking this central point 50 degrees Celsius, we have to go to the first graph. 50 degree Celsius. So where is the 50 degree? Here it is 50. So from this you just have to draw a perpendicular like this, and once it touches to this curve, then come to the downward direction, again a perpendicular, and it should cut to the x axis, and on the x axis we have distance x only, so it is 30. So you have to note down this also, the mean temperature and the x value, and likewise you have to plot another observation table by doing this, and that will be the third observation table, and this observation table is drawn here and it is submitted also. So d theta by dt means the value of slope of that corresponding point, and this mean theta mean, that is what we got 50 for example, d theta by dt, its mean value, and corresponding x value from first graph. Every time we have to go to that mean value, and we by taking that mean value to the first graph. Okay, right. Now here, once you got these 12 slopes and their corresponding theta value and x value, then finally we have to draw the graph between these two, d theta by dt and these new x values, and this will be the last graph. So calculations are little bit tedious in this particular experiment. All the things are almost simple. Now see, don't worry. So finally what I am saying, x on this axis, and on the y axis we have to draw d theta by dt, that is our slope. Okay, now once you got this graph, now again this is will be the smooth curve like this, and we have to consider the maximum number of points should go through the particular curve. Okay, right. Once you got this, then you remember that the formula for our k is equal to rho s dash divided by d theta by dx at x1 minus d theta by dx at x2. So these are the two slopes we got from the first particular graph only, and no problem, those two are rho and s already known to us. Rho is the density and s is the specific. Only unknown thing is now s dash, and this s dash is nothing but the area under this particular graph, area under third curve, area under curve, area under the curve, and that's what we have to measure, that is what s dash. Okay, so to measure the area under the curve, what we have to do, yes, just plot this particular point like this, means first point, initial point, and last point. So this is what the total area under the curve we have to measure. So to measure the area, we know already the boxes are drawn on the graph paper. So let us first of all find the area of first one box, and then count how many boxes are there or how many squares are there under this particular curve. So to find the area of one square, the area of one square is, we know, the x into y. Yes, the square is there. So whatever may be the scale on x axis and whatever may be the scale on y axis, if we make their product, that will be the area of one box. So it is simply 1 into 0.005, depends on your scale. Okay, how much scale you have arranged or how the scale you have. So take it, and that will be the area of one particular square, and then count how many squares are there. This cross means the square we have just for our counting purpose. So number of squares we got here 100 for example, then 100 squares. Okay, and let us consider area of one square is a1. So the total area s dash will be a1 into 100. Yes, you know, and that will be the s dash. Now s dash is known and remaining three things are already known to us. So substitute all the values and get the value for coefficient of thermal conductivity, and that's what we have done here. Finally rho s dash. So s dash we got like this. This is rho, this is s and s dash, and whatever two slopes we got from the first graph we have substituted here, and finally by doing the calculation by using log table we got this value as 0.1219 calorie per centimeter second degree. This is what the unit for the coefficient of thermal conductivity. Okay, so friends, don't worry, this is not that much complicated. The experimental part is very easy, as you have seen. but little bit what we can say, lengthier calculations are there, not complicated, only lengthier calculation. 3 graphs are there, 3 observations are observation tables are there, and that's why you may feel this is little bit complicated. But don't worry, have some patience, watch the video carefully and note it down each and every point. You will find it is very easy. But still you have any doubt, you can post in the comment box. And if you feel this is value addition to your knowledge, then like the video, subscribe for more such videos to our channel, press the bell icon for all the notifications of our future videos, and yes, share with your friends, right? So thank you friends, we'll meet in the next video with new concept, new practical. Till then, you'll keep watching, keep learning, and take care. Thank you.